Welcome to tutorial 4 on particles and the gravity engine. Here we have a new scene with a gravity engine, and we will go to our prefabs directory and add a star so that we have a source of a gravitational field. And now we'll add a standard unity particle system. We'll move that particle system to 15 units away from the origin. For this particle system to interact with the gravity engine, we need to add a gravity particles component to the particle system. And then the particles will be detected by the gravity engine and they'll be influenced by the gravitational field of the star. So if we press play, we can see now that the particles are being emitted with a velocity. The physics engine is taking that as the initial condition, and the particles are moving in the gravitational field of the star. And if you want to use the existing ability to control the shape and velocity with the particle system element, that all works just fine. There are cases where you may wish to directly control the particle distribution, their positions and velocities at the time things start. For example, in the case of a dust ring. So there's a mechanism to add an initialization script component to the particle system, and then it will take control and initialize the particles as required. So the source code for these components is in the particles directory under scripts. So there's a dust ball, a dust box, and a dust ring. We'll take a look at the dust ball component. So if we want to create a dust ball using script control, there's a dust ball script, and what it does is implements the iGravity particles init interface. And that really just means that it will be called to init new particles. It'll be given a range of particles and a reference to the physics arrays that hold the position and velocity for each of x, y, and z in these two-dimensional double arrays. And so the positions are filled in with a random value inside a sphere, and the velocity is initialized with the public velocity vector that we provide. So to make use of that, we'll add that component, dust ball. And what we want in this case from the particle system is for it to just create a bunch of particles at the beginning. So we will disable the looping. We'll make the particles long-lived. We'll set the start speed to 0 because our script will be setting the start speed. And we'll change the emission so that they're not emitted in a stream, but are emitted in a one-time burst of 300 particles at the beginning. And so now if we press play, our script initializes a sphere of particles. They don't have any velocity and they just fall into the star. Using this public velocity, we can give it some y velocity, and that will result in the ball particles all moving with that velocity at the beginning. The ball is spread out over a variety of radii, and as a result they orbit at different rates. So what happens is the ball gets spread out. Now the ball is something we could have done with the built-in unity cases, but an actual ring of particles with specific velocities based on their distance from the star would be a little bit harder. And for that reason, we have a dust ring script. And the dust ring script makes use of the ellipse parameters and expects to orbit around a central object. So in this case, we'll take the particle system and make it a child of the star. We'll set the orbit to 10 units. We can change the eccentricity if we wish. Change the shape of the orbit a little bit. And now if we press play, what we get is a uniform distribution of particles in a ring orbiting the way we've described. If we want to have a wider band, for example, an asteroid belt or something, we can press play. It is worth being aware that the particle systems are treated as massless particles, but they are evolved on every fixed update. And the more particles you add, the more work you're asking the game engine to do. There is the ability to fine-tune the performance of the particles relative to the rest of the bodies by changing this value here, steps per frame for particles, which you can set independently of the steps per frame for the non-particle objects in your scene. So if you're finding that your particle performance is suffering, you can try and reduce the number of steps per frame for the particles, or you can try and reduce the number of particles. Thanks for watching.